So this is how to find out if you have any association between two qualitative variables. I will just remind you the algorithm, the whole algorithm once again. So we start with computing observed and expected frequencies, right? So observed frequency is a very simple thing. For every combination of the levels from the two variables, you count how many values you have for this combination in your sample, okay? Then you compute the expected frequency, assuming that there is no association between the variables. And in this case, we just use the proportions for every variable, okay? When the expected and observed frequencies are ready, you can calculate a chi-square statistic, which is just a standardized squared difference between the observed and the real frequency. And then, because this statistic follows chi-square distribution with degrees of freedom equal to the number of levels in the first variable -1, the number of levels in the second variable -1, you just use this distribution to find a p-value, to find a chance to get a sample as extreme as yours or even more extreme, meaning that the difference will be even larger, the chi-square value will be even larger if the null hypothesis is correct. Yeah, and then the reason I use this R and C here, and before also, it's a simple thing, it's row and column, so how many rows and how many columns, because we use the table to represent the observed frequencies, okay? So that's the procedure, and as any test for association has some limitations. First of all, it works only if you have at least 5 objects for every combination. So if you see in contingency table, you see any combination with less than 5 values, you cannot use the test for association, okay? And then actually, the test for association sometimes in literature is called the test for independence. So it means that you have 2 independent qualitative variables. Okay. There is one significant limitation for this test. It doesn't tell you anything how big the association is. It just tells you, do you have association or not, or how likely do you have an association. But it doesn't tell you anything about the details. It's like ANOVA. ANOVA tells you if you have any difference or not, but doesn't tell you where you have this difference, right? In ANOVA, we make a post hoc test to find the details, and actually we can do the same for the test for association. And this, it's not a test actually; it's a calculation of standardized residuals. It's very similar to the chi-square statistics, but looks a bit different. First of all, we don't square anything because now we are interested in sign. We would like to know if the difference is negative or positive. Then you can see that we take the difference here, R and C. It means a particular row and column. For example, if you have a table like this, like we have, like this one, and you want to find the residual for this, it means that the average salary and the don't know R, then you have the small r will be 2, it's a second row, and the small c will be 2 also, it's a second column. Okay, so if you want to do it for this particular combination, the 2 and 2, so you just take a difference between the observed and the expected frequency, and then you divide this difference to the square root of the following. This is the expected frequency for the same combination, then this is the proportion for a given row. So in this case, it's a proportion, for example, for the average salary, right? And this is the proportion for the column. So that's the proportion for the engineers who don't know R, right? So the capital N, it's a total amount of values in your case. So you can calculate these standardized difference values and use them to see how big the difference is, how big the association is. The idea is following. These values are normally distributed, and they are distributed as a normal distribution, a standardized normal distribution. It means that average is 0 and standard deviation is 1. So it means that every time you have a value above 2, strictly speaking above 196, but we can think about 2. If you have a value above 2, it means that this association, this particular difference can be significant. So it's very unlikely to get this difference as big as this one, or even more, or even larger, if indeed there is no association. Okay. Let me show you a couple of examples. I will use the same sample as we had before. You remember we didn't find any association when we used a sample size of 50. And if you calculate the residuals, indeed, look, the smallest absolute value for the residuals we have for the low salary. You can see it's not extreme at all. I mean, the residuals should be equal to 0 if they are not extreme. But in this case, we have slightly larger values than 0, it's 0.1, okay? For the average values, it's 1.5, so it's much bigger, but still it's not big enough to see, to have an evidence that this difference is not just by chance. Then we have also quite big difference for the high salary, but again, it's not big enough to assume that it's not just by chance we see it, okay? But if we take a second sample with 150 values, then we can calculate, the calculated values will be larger, of course, in this case. For the low salary, we still don't see any difference, any association between knowledge of R and low level. But for the average and for the high salary, you can see the residuals are quite extreme, right? Then you can see this is positive and negative, and this is vice versa, negative and positive, right? What it means? It means that if you know R, it's very unlikely you will have an average salary, but it's more likely that you will have a high salary. So the distribution, the proportions between average and high salaries will be different for those who know R and for those who don't know R, while the proportion for the low salary will be about the same. So if we take this particular sample and if we look at these particular residuals and the test results, we can say that knowledge of R increase a probability to get a higher salary and decrease the probability to get an average salary. So it changed this ratio between average and high salaries, which in fact means that if you know R, you can expect a bit higher salary than those who don't know R.